the James Webb Space Telescope and the shattering of cosmic certainties. For generations, humanity has gazed into the night sky, searching for answers to life's most profound questions. Where did we come from? How did the universe begin? What is our place in it all? Modern cosmology, for the most part, has been shaped by the Big Bang Theory, a model that explains the origin and evolution of the universe from an unimaginably hot and dense singularity. Over decades, the model gained substantial support from observations, including cosmic microwave background radiation, large-scale structure formation, and redshift data indicating an expanding universe. Yet, in recent years, a new player has entered the scene, the James Webb Space Telescope, JWST, a marvel of modern engineering designed to explore the deepest, most ancient parts of the cosmos in infrared light. Since its full deployment in mid-2022, JWST has delivered a flood of high-resolution images and data that challenge much of what we thought we knew. Far from affirming existing models, Webb is raising profound questions about the nature, age, and structure of our universe. The universe revealed, what Webb is telling us. When JWST was launched, scientists hoped to peer back in time to the first few 100 million years after the Big Bang, to witness the formation of the first stars and galaxies. What they found, however, was unexpected. Instead of primitive, loosely structured galaxies, Webb detected well-formed, massive galaxies that existed far earlier than anticipated, some dating back to just 300 to 400 million years after the supposed Big Bang. According to established models, such complexity should not have emerged so early. This has forced scientists to revisit basic assumptions about the timeline of cosmic evolution. Some of the challenges include unexpectedly mature galaxies. Galaxies observed by JWST appear too massive and structured to have formed so quickly after the Big Bang. The time available for their formation doesn't seem sufficient based on known physics. Anomalies in stellar formation. Stars observed in the early universe exhibit characteristics like metallicity and brightness that suggest a much faster and more complex evolution than predicted by current models. Redshift inconsistencies, objects with extreme redshifts, indicative of vast distance and therefore great age, are being observed in greater numbers and with more diversity than expected. This raises doubts about our understanding of redshift as a reliable cosmological tool. These revelations indicate that our foundational understanding of the early universe may be deeply flawed, or at least incomplete. Roger Penrose and the Cyclical Universe, a new cosmic model. Among the few prominent voices not surprised by the growing inconsistencies in standard cosmology is Sir Roger Penrose, Nobel laureate and theoretical physicist. Penrose has long advocated for a radical theory known as conformal cyclic cosmology, CCC. In this model, the Big Bang is not the absolute beginning of time, but rather the transition point between successive eons, each representing a complete life cycle of a universe. According to Penrose, the Big Bang was not the beginning. In CCC, each aeon ends in a state of maximum entropy, with all black holes evaporating and the universe reaching a near-zero energy equilibrium. At that point, a sort of silent bang initiates a new aeon, creating a new universe with residual structure and energy from its predecessor. Penrose's model provides intriguing explanations for why galaxies and stars might evolve faster than expected. They could be inheriting structural blueprints from a previous universe. Why entropy appears to be low at the beginning of our universe, because it inherited a highly ordered state from a prior aeon. The persistence of mysterious signals in the cosmic microwave background that seem to point to past events predating the Big Bang. JWST's data, especially the presence of early and unexpectedly advanced cosmic structures, has revitalized interest in Penrose's theory. While still controversial and not universally accepted, CCC is increasingly viewed as a plausible alternative to the standard Big Bang narrative. A cosmic mystery, the vanishing of 771 trillion stars. Perhaps the most astonishing and unsettling discovery attributed to JWST is the apparent disappearance of approximately 771 trillion stars across various regions of space. This claim, based on comparative analysis of Hubble-era star catalogs and newer JWST data, suggests that vast numbers of stars, and by implication, their planets and systems, have simply vanished, without any observable supernovae, black hole formation, or expected physical causes. Such a disappearance directly contradicts one of the foundational principles of physics, the law of conservation of mass energy, which dictates that matter cannot be created or destroyed, only transformed. Possible explanations under investigation include instrumental or observational errors, though this is becoming less likely with multiple confirmations. Cosmic dust or lensing obscuration, where intervening material or gravitational effects hide these stars. Stars transitioning into exotic, undetectable forms, like primordial black holes or dark matter. Advanced alien megastructures, a speculative idea suggesting that massive extraterrestrial civilizations might be cloaking stars using Dyson spheres or similar technologies for energy harvesting. A fundamental misinterpretation of how light behaves over cosmic timescales and distances. Though this last point may sound improbable, it raises an important concern. Light, our deceptive messenger. Everything we know about distant cosmic objects, stars, galaxies, exoplanets, nebulae, comes from light. Specifically, the photons that travel across billions of light years to reach our instruments. But light can bend, shift, and distort as it travels. Some complicating factors include gravitational lensing, mass warp space, bending light in the process. This can result in galaxies appearing multiple times or in altered positions. Redshift and time dilation. Light from fast receding objects is stretched to longer, redder wavelengths, making those objects seem older and more distant than they might actually be. Interstellar dust. Infrared light can penetrate dust better than visible light, but some emissions can still be absorbed, misrepresenting the true brightness and size of objects. Instrument limitations, calibration errors, data processing techniques, and human biases can introduce artifacts or misinterpretations in the final imagery. Given that our perception of cosmic history hinges entirely on interpreting light, it's not impossible that some of our key cosmological measurements could be flawed. The redshift crisis and the age of the universe. One of the pillars supporting the Big Bang theory is cosmological redshift, the stretching of light waves due to the expansion of space itself. This has allowed scientists to estimate how far away galaxies are, and by extension, how old they are. However, JWST has discovered galaxies that seem to be older than the universe itself, based on redshift calculations. This isn't just a minor error. It strikes at the heart of how we determine cosmic age. Is redshift always a reliable proxy for distance and time? Or could alternative mechanisms, such as intrinsic redshift, interactions with dark energy, or non-expanding universe models, be at play? Conclusion: a universe in flux. The James Webb Space Telescope has not just extended our vision into the past, it has fractured our certainty. Once stable theories are now riddled with anomalies. Formerly fringe ideas like cyclical cosmology, hidden stars, and alien megastructures are finding new audiences, not because they are sensational, but because our most trusted observations demand new answers. Scientists now stand at a crossroads. Do we patch our existing theories with increasingly complex adjustments, or do we dare to rethink the universe from the ground up? Whatever path we choose, one truth remains unshaken. The universe is more mysterious, more complex, and more awe-inspiring than we ever imagined. The revolution sparked by JWST is only just beginning, and it invites all of us to explore, to question, and to imagine anew.